This is the two questions for this tutorial. This tutorial for module number 3 about wind, hydro, and otic energy. So we'll solve together question number 1 and question number 2 about wind energy. So for question number 1, ask to find amount of air. What amount of air in kilogram per second passes through a circular area with 120 meter diameter at 8 meter per second? And given note here, one assumption, assume an air density of 1.225 kilogram per meter cube. So this is the air density at sea level, equal 1.225 kilogram per meter cube. Ask to find amount of air in kilogram per second. Okay, so here, this is the question. We'll solve here. So from given data, أعطوني data. The first data given here, given the rotor swept area of rotor of wind turbine, given in an area circular area, only circular. So it should be find area. Should be know how to find area if given the rotor area as a circular. Given diameter, okay, to find this area, given diameter equal 120 meter, and given at 8 meter per second. So this is value of what? This value, given quantity, 8 meter per second.
Speed.
This is speed, yes, or velocity. So velocity of air here, of wind, equal 8 meter per second. Assume an air in density at sea level equal 1.225 kilogram per meter cube. So we're starting here, given area, not given as a number, but here given note, circular area. Also given diameter, D, equal 120 meter. Also given V, where V, velocity or speed, same. Speed or velocity of wind equal 8 meter per second. Also given the symbol of air density. Symbol of air density, this value equal 1.225 kilogram per meter cube. So symbol should be no chemical rho. This is rho of air, okay? And ask to find amount of air in kilogram per second, given symbol. Find amount of air in kilogram, yes, per second. Anyone know the symbol? Level 4. Amount of air, given also unit. Symbol of amount of air. Find Q. Okay, how to find Q? From given data. How to find now Q, amount of air. يلا level 4. Try to find rule of Q depends on the given unit here. level 4. حد يتكلم.
density في الاريا velocity
Density
times area
of air, yes, times
velocity.
times velocity. Then should be fine. Q equal to V times air density, where V here not equal to V small here, V small. I mean by V small here and V capital here in Q. So V small is the velocity or speed given in a question, 8 meter per second. But other V here is a volume. So Q will be volume times air density. How to find volume of air? No, we need the volume of air passing through a circular area. Every second, we need volume of air which passes through the circular area, because given area here as a circular, okay? Every second. All of this notes, new one should be fine. This is the first, this is the note for Q, but should be starting find volume first. So volume, we're starting from volume. So volume of air passing through given area as a circular area every second will be area times velocity, will be area times velocity. Okay, so area of circle, of circular area, how to find it? How to find area? Yalla, level 4. Should we know how to find area for the circle? Given diameter here. Diameter equal 120 meter. So how to find area? Before I will delete recorded. Given area for circle.
Two by R or
2 by R for a circle. Asking
by
question.
DC.
What? Should be pi R square. Okay? By R square. Where R radius. But we have here diameter. So will be
Divided by 2.
So will be, this is for area, okay? So this is area only. I will put in another place. So area for circular area here, equal by r square. But because given here diameter, so will be pi, and r will be d diameter over 2 square. So find area, then area will be pi times d over 2 squared, this is area, times velocity of wind. Okay, so find this value. If find this value, this is the first step. We'll find volume. Then volume will be times density of air, will given the amount of air in kilogram per second. So find volume, substitute by given data, given diameter, and we need also velocity, and velocity also given. Unit of volume will be in unit of volume.
Meter cube.
Yes. Per here per second, because given we need volume of air passing through area, circular area every second. So with respect to second, with respect to time. So when substitute here will be pi times diameter 120 over 2 square. Find this value or direct times velocity. Velocity given equal 8 meter per second. So will be by volume equal by times 120. Okay, this is in meter square. Okay, then velocity given equal 8 meter per second. So the unit of volume will be meter squared times meter, so meter cubed per second, given the value of volume.
$90,477.
No. Check please. There is a by here. By. Maybe yes, maybe I'm calculated with respect to by. Given the answer, given answer, I'm find this answer with respect to by. So if calculate value of by, given the answer here.
28,800
Yes.
with respect to
800.
pi.
Okay. Maybe the first solution correct, but I'm see without by first. So with respect to by will be this answer. If times by will give other answer should be same. Okay. So the unit in meter cube per second. This is the volume. Then we'll back to substitute in rule of Q, amount of air. This is called mass flow in chemical. Amount of air called mass flow. I'm asking now. I don't know what does mean by this unit, this symbol, Q. Given in unit kilogram per second, this is mass flow. Yes or not?
Yes.
Yes, miss.
Okay. So now we need Q. So Q equal to volume. We have a value of volume 28800 pi. Okay, meter cubed per second. This is a unit. Then times rho times density of air. So density of air given equal
1.225.
Yes, 1.225. So times 1.225 unit in kilogram per second. Yes? No. Kilogram per
Meter
meter cubed. Meter cubed, yes. Per meter cubed. So meter cubed will cancel with meter cubed. So we'll find now value of Q in kilogram per second. Same as asking in this question. So Q, find this answer here. Q equal, with respect to unit, kilogram per second.
It is 35,280.
No. With respect to pi? Or
Yes,
without?
miss. With respect to pi.
Without pi now. We need the
Now
final
without
answer.
11
Yes.
0835
Okay,
point
0,
something
8,
with
4.
points.
Then?
Yeah,
Point
0.38.
38. Okay. I have different, same number, maybe missing one number here. I have 1.1084 should be here times 10 power. If you take this value, will be 1.1 times 10 power.
Power 5.
Now, if take 1.1, will be power 5 or power 4 here? Depends on this answer.
4.
4, but I have power 5. So please check this answer.
Miss, you approximate the number. It's 3.5. You take it 4. It's appearing with me. It's 8.35.
Okay, I'm not talking about number now. هنا عندش 11084 عندش رقم بعدها بعد الفور before
لا
point.
مس هو
Wait.
الرقم 110835.
35 yes.
أيوة
Okay.
قبل البوينت 35.
Okay. So the answer, I will repeat this answer here, given the final answer now. 1 point.
1.1.
Point. If you want without point, okay. Given 11.
Yes, 08.
Okay. So same, should be same. 11808 0
0 before 8.
Yes, yes. Okay. 1 yes. Then 08
0835.
35. Okay.
Yes, 0.38.
0.38. Yes. Okay. So this is the unit which asks a question to find amount of air in kilogram per second. So we find it now. Finish this question. Question number 1. Any note here? Okay. Clear?
Yes, miss.
Okay. So for question number 2, assuming an air density, here given the value of air density rho equal 1.43 kilogram per meter cube. So this is rho of air. Calculate the efficiency of Nordex S77 with diameter 72 meter. So this is diameter, D, same as previous question. This one, this name, the Nordex S77. This is one type of wind turbine. This is only type, only name for type of turbine. فهي ما مهم بالنسبة لنا هذا only type. Okay, so we need here to should be now the value of air density equal 1.43 kilogram per meter cubed. Should we know also the diameter value given equal 72 meter. Also given in a table the wind speed in meter per second. Also given output power in kilowatt. and asked to calculate efficiency. So we need efficiency here in the table. Should be find efficiency at each value of wind speed, and depends on also on output power which is given in this table. So in table, given wind speed starting from 1, every 1 unit, so 1, 2, 3, so on to end by 90. So we have here 19 value. So we need to find efficiency at each point. Okay, so I will written again the data here. Given wind turbine, the type of wind turbine, Nordics S77. Okay, this type of turbine with diameter equal 72 meter. Okay, we have air density equal 1.43 kilogram per meter cube. Okay, given depends on a table, given wind speed in meter per second, also given the output power in kilowatt. How to find efficiency? Find efficiency. How to find efficiency in general? Depends on given data. You have turbine, okay? This turbine given the output power, okay? The output power of this turbine given, okay? Starting from 0 in second column, starting from 0, okay? We have 0 for output power when the wind speed is 1, 2, 3, and 4. So always we'll take the value of output power equals 0. Also, with respect to wind speed, starting from 13 here, from 13 to 19, always the output power equal same value, 1,500 kilowatt. So this is the value, same here. Also, this value will be same, 0. Depends on the velocity of wind or speed of wind. So we need to find now efficiency in general. How to find efficiency? We have output power. Okay, so how to find efficiency?
Output power over.
Yes. Now we have depends on power. So always efficiency will be output value depends with respect to input. So we have output value of power. So we need to find input power. So efficiency here, efficiency will apply the rule of P out to B in. Now the value of B out given here. How to find Bn? Bn of wind turbine. Step number 1 should be find Bn. Bn called B wind. شوفها في reference given as a P wind. How to find this value? This rule should be ما في حفظ الحين. Should be know the value of B wind equal 0.5 times air density, then times area, okay, times area, and velocity cubed. هنتأكدوا أنها cube, velocity of wind cubed. Okay, so this is the value of Bn or B of wind. And area, because given here area for the rotor, so circular, because given diameter equals 72. So area, how to find area? Area will be again same as the previous question, so will be by r square. So r, this is a radius, given diameter, so will be diameter over 2. Okay, so in general, in first step, B wind, again, we'll substitute here by area. So will be 0.5 times air density times by R squared, so D over 2 squared, again times V, I mean speed, this is given also in a table, cube. And answer should be given in kilowatt, should be solved by kilowatt. Why? Because the output power given in the table in kilowatt. We need to divide the output power to input power, so it should be in same unit. So should be fine now. The input power of wind should be fine in kilowatt. So we need to find how many values? 19 value depends on a table given 19 values. So we need to add here, instead of efficiency first, should be find B in a table, should be find Bn. Apply this rule. So find Bn 19 values. Every time should be find efficiency by B out to Bn. Okay, so this rule of Bn depends only on, will be different from one value to other, depends on what? Should be given different value, depends on 19 values, depends on given data of table. So depends on what here? Because 0.5 constant, pi also constant, D also constant, diameter constant given. So will be same for all values, 72. So depends only on
Speed.
velocity, speed
Wind
or
speed.
velocity. Yes, depends on when the speed will be changed from 1 to 90. So I will solve with you only sample. We'll take a sample from this table. So we're starting now from 1 to 4. Okay, when wind speed from 1 to 4, the output power equal 0. So we'll choose only one. So we're starting from first value. So P out will be given equal 0. And Bn will apply now rule, depends on this rule, will apply, will change only the velocity, depends on 1, 2, 3, 4, should be used as cubic value. Then efficiency here will be, anyone know? Efficiency?
0.
0. Direct will be 0 because B out equals 0. So when find this value of Bn, so Bn will be 0? No. We'll find value for Bn. But for efficiency, when find the first 4 values should be equal 0. Efficiency here equals 0. Okay? So we'll start and choose the first value. When velocity or when the speed equal 1, we'll find the first value. So we'll apply for V of wind equal 1 meter per second. So we need here to find Bn or B wind. I mean this value, Pn or P wind, same. So it will be 0.5, okay, rho given equal 1.43, okay, by constant, diameter given equal 7.2 over 2 square, and velocity here equal 1 cubed. So 1 will be 1. Otherwise, for other values should be check, this is cube here. So given value in kilowatt.
Two thousand 911.1.
2,000,
900.
1,000, okay. 900, okay.
11.
Okay. Yes.
Point 12.
Point 12,
Yes.
okay. Unit, watt, yes.
Kilowatt. Watt or kilowatt?
I'm asking.
What?
Watt.
This is watt. We need in kilowatt because given in the table, P out in kilowatt. So we need to divide it again. So we need in kilowatt. So this value will be
2.91.
Yes, 2.911 kilowatt. So can now find efficiency for the first value of speed equal 1 meter per second. Therefore, efficiency here equal B out to Bn, and B out equal to 0 over any value will be 0. So equal 0. So this is the first value of efficiency at velocity equal 1 meter per second. Okay, clear? طبعا in exam if given same as this question we're given maximum 3 to 4 to 5 maximum, not given 19 values, because the rule same. So when apply the rule for Bn, we need to apply rule of Bn and apply rule of efficiency. So we're given 3 or 4 or 5 maximum values. Okay, so here for the first value of speed given efficiency equals 0. Okay, we'll choose other value. Okay, for example, if it choose for example 6, velocity or speed equals 6 meter per second. At this value, output power equal 151 kilowatt. So we'll start and find first Bn. So for the wind equal 6 meter per second. Please try to find this value, Pn. We'll apply again rule. Will be 0.5 times rho, where rho 1.43 times area, and area equal pi times d over 2 square. I mean r square. So 72 over 2 square times velocity cubed. So 6 cubed. So Pn, P wind, I'm not calculate this value, so try to given correct answer here. Equal
628.8 kilowatt.
600. Again, please.
628.
28, yes.
0.803
8, okay. 80, okay.
kilowatt.
In kilowatt, yes.
Yes.
Okay. Okay. Then efficiency will be P out again. We'll see now the value of P out from table. So P out at 6 meter per second of velocity given equal 151. So 151 kilowatt divided by 628.80. Always Bn should be greater than B out. Okay, Bn always greater than B out. Should be given here the value as a percentage fraction. Okay, so equal to
0.2401.
0.24.
Yes.
Okay. We can find also efficiency as a percentage of times 100. Okay. So for the last values from velocity 13 to 19 here, okay, we can find direct efficiency. Calculate for one value, then efficiency will be same here.
No.
No, miss.
Why? Why?
The Pn
Because
is
the velocity. Yeah.
Because of Bn not equal. Okay, so Bn will be different, depends on V. So we have here V equal 13, so we'll use 13 cubed, then 14 cubed, and so on. So the value of Bn will be different. So also velocity depends on Bn will be different. So we'll use the last one, then I will give you the table of value. So we'll use 19 here. Okay, So we'll find same steps for V wind here equal 19 meter per second. Again, we need Bn will be 0.5 times rho 1.43 times by and r squared. So r squared will be 72 over 2 square. This is area. So this is area times density, power density, air density times 0.5, then times 19 velocity cubed. So please find this answer. Then find efficiency. Now in table, when starting, the first value of Bn was 2.9, always will be increased. Why? Because it depends on V cubed, and V cubed every time will be increased by 1 unit. So when you use 1 cube, we find 2.9 because all values same for all value of V, only changing in value of V cubed. So here the first value 2.9, then will be increased, then increase at 6 was 628. Now at 19 should be more, greater than previous one. So equal
19,000.
Yes.
967.4.
Yes. 0.41. This is now in kilo or in what?
Kilo.
In kilo, yes. So high number here 19967.409 kilowatt. And the value of P out given 1,500. So 1,500. So efficiency will be 1500 by 19967.4. Find efficiency.
.0751.
Yes, 0.0751. So should be solved for all table which are given here. So I will upload the solution. This is a solution. This is the table. Depends on wind speed here, starting from 1 and by 19. The P out, the first and second column given in a question. So Bn, B wind, I mean, in kilowatts, given in column number 3. Then the efficiency depends on P out to Pn. So the first 4 values was 0. Okay. And the last value here, now given here different number depends on a rounding. Okay, so we find the last value 0.0751. yes, efficiency اللي قبل شوي وجدناها 0.0751. here given 0.0877. so depends on a rounding here. We find before this value equal 1996, I think 7, yes, 67. Okay, so approximately same. So this is the table for question number 2. Okay, so this is our tutorial for today. You have any note? Now ask, please. Okay.